How does technology enable product innovation? Well, the answer lies in connected product innovation, which is essentially IoT sensors, field service, sales, factories, and the supply chain all working together towards faster innovation. This means real time insight into which products and features customers are using without having to wait for customer survey results. The automotive industry is doing this on a massive scale, with the data coming in from their connected vehicles and also from fleets of specially instrumented autonomous vehicles. Dr. N. Sarvanan, the Chief Technology Officer at Ashok Leyland, and Ventakesh Natarajan, the Chief Information and Digital Officer at Ashok Leyland, now share their experience and learnings with Microsoft India's country head for manufacturing, Pravin Panchagnula.
Hello, everyone. Welcome to Future Ready for Manufacturing. This is Pravin Panchagnula, country leader for manufacturing, Microsoft India. The manufacturing space has always been focusing on quality, on continuous process improvement, on supply chain efficiencies. What we have seen as a trend in recent years is especially the change in the customer behavior, and that leading to the entire front office transformation. So that is something that should, today, if you look at it, there are products which are connected. So you're connected with the customer, not just at the point of sale, but over the entire life cycle of this journey till a customer comes back and becomes a repeat customer and a true ambassador once again. One such example is the automobile industry, which has always been at the harbinger of technology. With connected vehicles coming up in a big way, the entire automobile industry is today engaged with the customer over its entire journey. And that's kind of redefining the entire ecosystem and also the business models in this space. A leading player in this space is Ashok Leyland, for example. It's the company which manufactures the first electric bus in India. And today, to our privilege, we have eminent panelists from Ashok Leyland with us. A very, very quick introduction. We have with us today Mr. Ventakesh Natarajan, President and CDO Ashok Leyland. And together with him, we have Dr. N. Sarvanan, President and Chief Technology Officer of Ashok Leyland. Thank you once again, and let me very quickly deep dive with my first topic, VN to you, and I'll take the liberty of saying V, and that's how you are most popularly known as. VN. We have been using this acronym CASE for a very long time now. Connected, autonomous, shared, electric. I think it's been more than 5 years that this acronym has been played. Okay. Your thoughts on how much have we progressed as an industry on CASE?
Pravin, first of all, thank you for that wonderful introduction. The automotive industry has been in the cusp of major disruption, riding on some mega trends called, popularly called as CASE, connected, autonomous, shared, and electric. It applies to the global automotive industry, and it very much applies even to the Indian automobile industry. And you have digital technologies and a lot of these cocktail of technologies enabling these very, very mega trends. But if you look at the commercial vehicle industry and from a India context, there is a slight redefinition of this CASE, right? So we are now calling CASE as connected will remain, because that is the very foundation for whatever you build and whatever trends you're building as part of CASE. So connected instead of autonomous, because autonomous from India perspective, we are at least, I would say at least about 15 years away. There's quite a lot of work to be done in India in terms of our infrastructure. We need to get our roads right. We need to get our traffic lights. We need to get our other infrastructure in place before we go full steam on autonomous. Especially, I want to re-emphasize and reiterate that it is low cost, which will be very, very useful in the commercial vehicle industry from an Indian context. And why is this important? If you look at the road accidents in India, it's pretty high, the percentage of road accidents and the number of fatalities. Yes, and we are redefining from shared to sustainability. Now you suddenly find that, the world seems to be moving full hog on the EVs and even other forms of energy also. It could be LNG, it could be CNG. And especially in today's context, when the fuel prices in India are all skyrocketing, people are looking for other forms of fuel. So, and keeping in mind sustainability. So S, shared, is replaced by sustainability. And the last E, when you say in the standard case, it is electric vehicles. Here we are talking of e-mass, because you are seeing this trend in India, especially in the bus segment, where the state transport undertakings are coming out with tenders. Many of these tenders are for EV vehicles, and it is on a mobility as a service model. So the auto industry also seems to be, following the IT industry in terms of a consumption-based model. So typically we are getting into a cloud-based kind of a model where customers don't want to own the vehicle. So having said that, what is it that we are doing? Our telematics journey, we used to call it telematics and then later started calling it as connected vehicle. It all started way back in 2005, where we had devices which are basically for track and trace. And then you had the product technology, engine technology also maturing. And when we had, we had a lot of vehicles which are fitted with these devices, and we were offering track and trace solutions and derivatives of that in terms of insights to customers, in terms of harsh braking, rapid acceleration, geofencing, using geofencing facilities, and so on. And then when we launched BS4 a few years ago, we started capturing quite a lot of data from the engine itself, right? And using that data, we not only provided track and trace facilities to our customers, but we also started providing certain vehicle health monitoring systems. We call that as Hawa Pani Tail strategy, which actually translates to Hawa, providing the customer air brake pressure, Pani, which is the coolant temperature, and then the tail, which is the oil pressure. These three parameters are very critical for an engine, efficient engine functioning. So from BS4, right, that's where we coined this connected vehicle, with vehicles becoming more and more connected. You had more aggregates. 2 years ago, when we launched BS6, that's a completely connected vehicle. The number of aggregates from where we capture data has also gone up significantly. In fact, the volume of data that we capture on BS6 as compared to BS4 is 18 times more, right? And a lot more of data parameters. And this is providing us an opportunity to provide a host of services and solutions to our 5 Cs who are the beneficiaries of this. The 5 Cs are our customers, our channel partners. Third is our collaborators. Fourth is our various other stakeholders like our transporters and so on. And lastly, the community as a whole. So today, we use this data very extensively, both for direct monetization and for indirect monetization, providing huge amount of value to not only our customers, but we have an uptime solution center here where we monitor all the vehicles, the health of the vehicles. We are able to do it through the internet, and we are one of the first organization, commercial vehicle automotive manufacturer in India doing this. So looking forward, the whole, as this industry moves slowly, transitions from a product-centric to a solution-centric kind of an organization, your connected vehicle, data, AI, analytics is going to play a very, very dominant role in this whole kind of a disruption and migration going forward.
Thank you so much, VN, especially pick up your point on 5 Cs. And Dr. Sarvanan, I saw the caption of Ashok Leyland, which is Aapki Jeet, Hamari Jeet, and that's the true sense of 5 Cs. And today, as was mentioned earlier, it is not just about the customer, it's about the entire ecosystem. A customer knows about our product right before he actually even visits us. So right from prospecting stage till onboarding and making sure we are connected with the vehicle. As a chief technology officer, I remember the traditional days when chief technology officer was looking more at quality, productivity, continuous process improvement, R&D, new product development. So would be absolutely looking forward to hear your views of how are you looking at this space evolving, and how do we leverage digital technologies towards and leveraging data towards making sure that we have an absolutely integrated platform?
I think very, very, very interesting question. I think let me start with sort of the bigger picture, right? I think if you look at the bigger picture, we are moving away from selling a product to selling a service. If you look at a typical customer, he spends only 15% maximum out of the entire lifetime sort of what he spends on the vehicle purchase. Plus 88% is there to be taken. I mean, when I say taken, it is a value that potentially we believe as OEM we can add a lot of value in 80% of the spend he has. Whether there's the diesel pricing or whether it's the tire pricing or whatever driver pricing. So I think it is important that we look at how do we sort of add value to the customer for the rest of the entire lifetime. The focus is now on how do I sort of move away from just selling a product, actually providing a service. To provide a service, we have to be efficient, right? I mean, do we understand what does it need, when does it need it? For example, even diesel, if I can actually bring about a 5% improvement in terms of diesel consumption, that's a benefit. If I can actually even prevent diesel theft, for example, by using data, that's a benefit. If I can accurately tell him your vehicle is going to need service customized for him, not just saying a vehicle needs service 40,000 kilometers for everybody, but based on this application, we can tell him your vehicle only needs service 80,000 because all these are sort of data driven, which we had talked about in terms of having ILR, but actually using the data to give the customer a customized experience in terms of his operational cost. I mean, that's sort of one stream of thought. So the data itself becomes much more critical in commercial vehicle than passenger vehicle because the commercial vehicle driven by TCO. He doesn't buy a truck because it looks good. He buys a truck because it provides livelihood. So the data itself becomes much more critical in the case of commercial vehicle than in passenger. That's sort of the fundamental, right? So how do we look at from technology perspective? How do we actually enable the vehicle so that it is ready for being a part of the mobility as a service platform? That's the key. So it might actually be putting in additional sensors, specifically for the purpose of making it much more useful in a EMAS platform. Things like that is what we're looking at. From a development side, of course, given the competitive nature, the fact is that you have to have products coming out much faster. So we actually have looked at digital all the way from gathering requirements from a customer perspective, looking at the concept stage, 3D data coming from all the way from concept stage all the way back to manufacturing, like a single source of truth from that perspective. A lot of the virtual simulations are happening. A lot of the sourcing getting digital because the whole chain has to be digital now, so that there's visibility in terms of what's happening at every single point for us to be able to crash the timeline and so on. So I think from product development perspective, a lot of effort is going on, making the entire thing more transparent, more digital, a lot of effort in terms of putting in a lot more data sensors on the vehicle itself so that when it becomes a part of the EMAS platform, it becomes much more useful. And from ecosystem perspective, how do I actually take the data and sort of monetize it?
So, Vian, you actually gave me a perfect segue into the next question that I had in my mind around this popular term which is going around software-defined vehicle, SDV. Okay. So since we spoke about, Dr. Ines mentioned about how we are making the vehicle more transparent, having enough and more sensors, and you kind of encapsulated very beautifully that we are not building a computer on a car today, but the other way around. So your views on what is exactly software-defined vehicle, and especially in the Indian context, how do you see we are placed as a country, and any thoughts about how Ashok Leyland would want to venture into this space?
So with all these, with technology really going up in vehicles, so today we call it as a software-defined vehicle. And if you were to ask me, what is the architecture of the software-defined vehicle, which is quite different from a conventional, traditional kind of an automobile? We see three layers in terms of a software-defined vehicle architecture. You would have the bottommost layer, which is your hardware layer. And then you have an IoT layer, which is the second layer, which sits on top of the hardware layer. So we need to be now looking at every aggregate, every component which needs to be sensorized, and that should be from a value perspective. The third layer is your cloud layer. Now we are now saying even today in our architecture, all the data gets into the cloud today. So it goes to the cloud, and cloud becomes your orchestration platform in terms of value delivery, because it kind of powers two things, two engines. One is your experience engine, using that data on the cloud and building applications which will deliver significant kind of an enhanced customer experience. And so that's an experience engine. And the second is your monetization engine in terms of how do you use that data, applications, insights, analytics, and all that for you to be kind of monetizing, data. So this is a kind of a 3 or a 4 layer architecture that we see. And this is not very easy. It sounds very, very simple, but your entire design philosophy of the automotive industry will have to undergo a complete rejig. Because the moment you start, a design engineer sits before his computer and then opens the CAD, I think he will have to have this in mind when he starts really designing. So that kind of calls for a mind shift change and a culture change in the way you approach design itself. And what are those technologies which will kind of turbocharge this whole architecture? You're going to have 5G. You're not seeing that in India, but there are a lot of trials which are happening. But I think 5G technology would have a profound impact on the automotive industry in enabling a lot of things which would be made possible through the 5G technology, and assuming that your infrastructure is also spruced up to support this. Number two, your 5G will enable 5G is one technology, and the other one is your edge computing is significantly go up riding on this 5G technology. So what you were probably doing on the cloud, there could be applications and use cases which would demand that you do a lot of compute on the edge itself. And when I say edge, it could be on the device, or it could be a small kind of a server which is very, very close to the point where the data is generated and sourced. So these two will really power the future generation of automobile going forward.
I think just to add.
If you want to add something?
Yeah, just to add this comments in terms of, you're right. I think the big challenge I see is in terms of skills, right? I mean, you have a typical automotive engineer, probably more mechanically inclined than anything else. I think now you start looking and saying, my vehicle architecture is probably equally important from a software perspective. How do we make it modular? How do we make it easily integratable, right? For example, in a typical automotive, you have multiple suppliers working on multiple systems. Mechanical integration is much easier because you know physically how it is done, you can test it out. But imagine each of them have a million lines of code. You have 10 suppliers. Just integrating that code itself is going to be challenging. So the idea is, how do you start looking at it a little bit differently so that the integration of software itself becomes simpler, right? And that's a challenge that everybody's facing. I think it's defining the architecture, having the skills in terms of actually being able to, if not write the code, at least start with proper integration of the code, making it modular and so on.
Today morning, I was reading a white paper from Microsoft on the advent of 5G. To your point, Vian, that you mentioned that the entire 5G, and we are making a lot of investments in that space, making the entire Azure platform 5G enabled. And Dr. N.S., you have been leading product engineering for a long time now, and it's changed quite a bit now with the three-level architecture coming into. You've got the mechanicals, the sensorization, the data models coming into picture. What is the role that technology like high-performance computing, on-demand cloud technology, or an enabled ecosystem of partners in terms of PLM? What is the role that you see these technologies and platforms will aid to accelerate this product innovation, the way HPC on cloud is all about? So any thoughts around that direction?
Yeah, absolutely. I think if you look at even just start the product development aspect, right? It used to be that most OEMs are independent in the sense they can develop everything in-house and do it, develop in-house and sort of integrate themselves. As technology changes and much more rapidly, also variety of technology. For example, the same OEM has to work on not just diesel, but electric vehicle, fuel cell vehicle, maybe a LNG vehicle. There's a need for more partnerships, right? And I think when you start working with partnerships, the challenge is much more, not just in terms of business relationship, but more in terms of technical data sharing. How do I work seamlessly with a supplier? So I think not just hardware, but also software. That's where I think a collaborative work environment, right? I think the more collaborative we can be, even in the design stage, the better off you are. So I think the PLM itself, while there are some tools, PLM, how do I actually make the PLM, use the PLM to actually work much more collaborative, data sharing, back and forth, transparently, of course, keeping into account all the IP challenges and all that. But I think that's the key. In fact, we have on our PLM, a lot of the partners accessing it directly. Of course, some firewall, but typically they have access to all the models that are relevant to them so that the work happens 24/7 in a collaborative manner. And that is sort of a critical path to it. I think to me, the critical is trust has to be there between the OEMs and from a data perspective, sharing and looking at them as partners, not just as suppliers.
The impact of high-speed computing is similar to the impact of high-speed commuting, right? So the moment you're able to cover distances very quickly, for example, Chennai to Bangalore takes 4.5 hours. If I have a bullet train which can cover this distance in 30 minutes, you can see it opens up a whole new world of opportunities in terms of development of trade. You're going to have cities merging. Chennai and Bangalore can merge one day because of the high-speed commute. So similarly, the impact of high-speed compute or high-performance compute, whether later it's going to be through quantum computing or whatever, the impact of that on society, on business is going to be very, very significant and enormous impact.
No, absolutely pertinent. I think it's a very interesting time that you're looking in. And while technology seems to be keeping pace with what's required and changing business model, I think one area that is going to make the huge amount of difference is in terms of skilling, both internally and externally. And internally is still relatively easy to manage, but especially the frontline workforce. And these frontline workforce is very often our own employees, but more often than not, these are also employees of our extended ecosystem, be dealers, distributors. We're keen to understand from you how technology can play a role in terms of making sure that the front line is well enabled, well skilled, and well collaborated on an ongoing basis. And
if you look at our sales staff, very efficient, but are they equipped for this new way of selling and doing more and more of value selling is a question we have been through. And how do we see technology and digital playing a role? The way we look at it is technology and digital in a very, very competitive landscape, especially in the commercial vehicle industry in India. Where 15 years ago we were probably only 2 players, and today you have more than almost 10 players now, and more pitching their tents in India. The landscape has become very competitive. So the way we look at technology and digital is technology and digital plays the role of an air force. And in a modern warfare, war is not won without the support of the air force. The air force provides the air cover that is required for the ground staff, the army which is fighting the battle. So the army here is our sales force here. And the air cover we provide is through technology and digital tools. So the way we look at, we are trying to kind of empower our sales staff with arms and ammunitions. So this is like, our soldiers, our field staff being like an Indian soldier. Today, those are all equivalent to the tech and digital tools. And we are looking at how can we equip these sales staff, the front end field people, to fight the battle with more and more of arms and ammunitions, and also train them, because just having arms and ammunitions is not really going to help. You need to have a very vibrant kind of a learning platform, training platform to tell them how to use those arms and ammunitions. So there's a lot of things which we are doing today in terms of empowering our field staff to fighting that battle with a lot of analytics, right, to improve their value selling. We provide a lot of insights in terms of the dashboards, which we provide data and insights from our connected vehicle platform, which is our iAlert platform. We use a lot of AI and ML in terms of providing them, again, arms and ammunitions in the form of forecasting. Whenever a salesman goes and meets the customer, he has a list of, for example, a parts executive. He has a list of parts which the retailer would be buying, which otherwise he would not be really placing an order. And there we use the recommendation system. I'm just giving you 1 or 2 examples of this. But there's a whole lot of digital enablement that we have built to enable the front line to fight the battle on the battlefield, which is becoming very, very fierce and very, very competitive.
Just to add to that, right, let me give some context. Typically, what does a typical OEM sell these days? Commercial vehicle, a diesel engine-based vehicle. So the front line knows how to sell a diesel vehicle. It's based on initial cost and nothing complicated in a sense. Service guys knows about diesel engines. He services it for his entire life, 30, 40 years. Imagine 5 years from now, certain percentage of the vehicles move from diesel to electric. Some more move from CNG, some more LNG, some more move to maybe fuel cells. So now suddenly the same front-end sales staff has to work with not just initial cost, but TCO-based model, EMAS-based model, customize sort of the offering for each customer, right? Comes to service. The same service guy has to be retrained for dealing with electric vehicle on one side, next customer is a fuel cell, next is LNG. I think it's impossible to achieve the level of skilling, training, the configuration, customization that the sales guy has to communicate to the customer without digital tools. So therefore, the digital tools, whether it is we have a configuration management tool or we have a services calculation tool, AMC calculation tool based on existing data or old data from the customer. To me, skilling at the front end has to be continuous and can only be done digitally. I do believe use of VR, AR tools become a critical role in terms of not just training, but also troubleshooting, diagnostic, prognostics, right?
So a final closing thing for what NS said was the way we look at digital tools and those applications which kind of help the frontline field people. We very aggressively look at ways and means by which we can kind of automate. So we use this strategy called look at everything and then quickly assess whether you can appify, whether you can botify, whether you can cloudify, whether you can gamify, and then whether you can cashify also from a monetization perspective.
Absolutely pertinent views, and we would, as you rightly said, very concluding comments. We spoke about a lot of stuff, how this entire industry is disrupting, and this time the disruption is happening from the front office side. And it would mean skilling, it would mean data, it would mean new business model, it could mean product innovation, all of it led by technology. And it would we need to really see the big challenge is going to be skilling and changing the tires as we move. I would redefine case into our own parlance as cloud, analytics, sustainable, of course, but also making sure that we have the right ecosystem and engineering available along with the right skills. So cloud analytics, skills and engineering to really partner with this change that industry is facing. And any thoughts from your side, NSVN, to conclude as Microsoft, as our portfolio, how do we kind of support this?
No, I think let me give you a brief. I think you hit the right word, ecosystem. So you need to start working with partners like Microsoft to say, how do I collaboratively so that I build this ecosystem, I contribute to it, right? At the same time, I'm able to utilize that as parts that are already there. To me, that is a key.
And when I say partnership, it is both an internal partnership within the organization and then external partnership with very people like Microsoft. So the chief digital officer has to partner very closely with the chief technology officer, and that has evolved over a period of time. This relationship has evolved over a period of time where technology started playing a very major role in the product, in the business, and then it became a kind of a welded kind of a relationship between the CDO and the CTO. And today I would say it is like a monocoque body. In a monocoque body, this is an automobile term, right? There is no separate chassis. It's all cast into one. So the relationship between the chief technology officer and the chief digital officer is like a monocoque body. And so it becomes very critical that the teams from the product development and from IT and all the functions work as fusion teams moving forward.
I have been experiencing this firsthand, and I can't compliment more on this. As you really mentioned, we need to balance off this microscopic and telescopic priorities that we have of running day to day and kind of building for future. And that would only be possible when the CTO and the CDO functions actually complement each other and form that single monocoque chassis. So with that, I would really conclude this. Absolutely wonderful thoughts. Thank you so much for taking the time. I'm sure our audience would have enjoyed it as much as I did it. And thank you once again for your time and for your, more importantly, also for sharing your thoughts with us.
Thank you,
Dr. Ness.
Thank you. Pleasure. Thank you very much.